Hello and welcome to the Sharper Than Phisher Soup, the story of an email autopsy presentation. My name is Alex. Right next to me is my colleague, Jonas. We are a couple of security analysts working with security, as you can see. And for the next 40-45 minutes or so, we are going to show you how we handle phish events in our environment. And you can just take it like a small process, a walkthrough, things that you should consider in your environments as well. So, everything starts with an end user, of course. He receives an email, he does not know if the email is legitimate or not. He at least considers it to be suspicious, and guess what? With whatever mechanism you have in place, he just sends it over to you, to the analyst. Their email reaches your queue, and you need very quickly to see, hey, is this really suspicious? Maybe if this is suspicious, maybe it's malicious. What can I extract from that particular email? So the first thing an analyst should do is the so-called context analysis. What this does mean? So you open the email and just take a look at the information within the body. Does the story behind the email match with, I don't know, the sender and things like that? Does it make common sense? Is it okay? Is it suspicious? Well, if it's because you're the analyst, if for it is suspicious, then maybe you need to correlate with additional data, which can be found, of course, in the email header. When you have decided that this is suspicious and needs further analysis, then you should concentrate on the data of interest, which can be attached files, which can be URL tags inside the email's body, and things like that. You need to be able to demonstrate the malicious character of the specific of that email, of course, and you need to also be able to extract the information from there. So, talking about context a little bit, you receive such an email, and yes, I have pulled a few samples for you. You should take a look at things that define a phishing attack. Things like sense of urgency, typos, bad grammar, inconsistencies. So you receive this email and it says, you know, this is very, very urgent, and I'm from Microsoft Office 365, and you need to do something with your account. And just by taking a quick look, well, it does not seem like it's coming from Microsoft. And, well, I'm not sure that actorbeard.com is a domain related to Microsoft. At least for me, it's suspicious when I see such an email. So, another example, and this one is one of my favorites, and from my perspective, it just yells at you, hey, I'm a fish, I'm a fish, I'm a fish. Why? Well, the first thing that you should at least see is that it's supposedly coming from Victor, and somehow he sent himself as George, so at this point I'm not sure who I'm talking to. And just by the details here in the email's body, it's a mess. So is it something related to a previous correspondence? Is it something that I have requested, or should I advise someone to do so? And the way the document is presented, well, I would expect that. So if I am to receive an attached file, I would expect to see it as an attachment, not as a shortened URL path within the email's body. Another example is the infamous CEO fraud. So you might receive at some point an email coming from, supposedly from the CEO, targeting the CFO. And guess what? Yes, this is urgent as well, and something related to some payment. And hey, why didn't we pay this amount of money already? Because, as you can see here, we should have done it the past Monday. So, and hopefully, this is not the way someone is approving payments in anyone's environment. So, I hope that it's not done via an email. And what happens if the email address of the sender is very, very, very well spoofed? And I have seen poor spoof attempts just by modifying a few characters here and there, but some of them look like the legitimate email address of your CEO. Well, yes, you take a look at the details in the body and you start wondering, I really don't think that this is actually legitimate. But you know, I do not have a direct line with my CEO. So I need to further investigate, and I need to further correlate data. And here comes the power of the headers. And I'm going to pass now the mic to my colleague, No, I'm not going to press my because I have a test set. And he will show us what information you can find within the headers of the emails, how to look for them, and how can this be correlated with the context analysis that we have performed so far.
Thank you, Alex. Okay, so like my colleague just mentioned, sometimes it is not enough to just look at the context of the email in order to draw a conclusion, to say, okay, this is a legitimate email, I can open the attachment, I can click on the link. No. You will need to dive into the message headers. And you do that because nowadays every email communication leaves a trace. It creates some fingerprints that are added inside of the message headers. Because of that, you are able to get them, analyze them, and look for any suspicious activity, for any suspicious pieces of information that don't seem to add up with the context of the email itself. There are a lot of email headers out there, and a 45-minute presentation won't cover all of them, it will take hours, but we'll present a few headers that, from our perspective, need to be taken into consideration when it comes to drawing the conclusion. Is this email legitimate or is it not? Then we do that with caution because we know that email headers can be easily faked by the attacker, and that is why when it comes to relying on some headers, we always trust those that are added by our own email servers and our security mechanisms. Okay, so in this field, we have a list of servers that the email has passed through. Basically, the received headers give you all the servers and computers through which the email traveled in order to reach its destination. And for each hop, it will generate one received header. Here you can find the server that got the email, the server name and IP address of the machine that it got it from, the timestamp details, and occasionally you can also find the email address to whom the message is intended to, and not to mention the fact that you usually get the additional information regarding the SMTP server software that was used to send emails for a particular hub. Next, the next header that I always take into consideration because I find it very useful is the message ID. The message ID is a globally unique identifier that is attached to every particular message. Whenever an email is sent from one point to another, the host that generates the email itself will also stamp the message ID. And we have a few examples with some message IDs that were sent from Outlook, from Gmail, from AOL, and from iCloud. And as you can see, at the end of every message ID, at the end of every string, you have the domain of the sending server. And the internet message format that standardizes this process mentions that this should be generated by that server. It's not mandatory. And you can see exactly the domain from which the email came from just by looking at that. And it becomes very useful if you want to determine if the email was forged or not. And I'm going to give you an example. Let's say that one day you receive an email from lawford.com, a law company, and the message it states that your company has been subpoenaed, you have 2 weeks to show yourself in court to present some legal documents. Or it also tells in the same email that you can scan some contracts, some useful information that are consistent from a legal perspective, and just send them as an attachment to another email address or to upload them on a website or something like that. And like my colleague said earlier, sometimes the email is spot on. The grammar is perfect. The signature of the person that sent you the email looks very nicely done. It has a few links that redirect to the official webpage of that law firm, and I'm just about to reach and grab my phone and call my lawyer. Come over here if there's something wrong. But I don't think that this is still a legitimate line. I still have a hunch that something's not quite okay. So I analyze the message headers, of course. And what do I see in the message ID? Well, it tells me that the last part of the message ID, the last part of the string, has a domain that doesn't add up, that doesn't match with the one with lawful.com. And of course, the first thing I do, I research, I Google it, see exactly what does that domain stand for. And I discovered that it belongs to a Vietnamese company that produces shipping containers. So at this point, I'm in a little bit of doubt. So how many of you consider that this would be a legitimate email? Raise your hands. Nobody. Okay, so the law firm that's based in Chicago has nothing to do to the Vietnamese company. That's correct. And that is what the message I give. One of the most useful things we can take into consideration when it comes to declaring, when it comes to making the assumption that the email was sent from a legitimate source or not.
But you should always be extra careful because also this header can be forged. So use it wisely and use it always in correlation with additional data. So you have to grab lots of details in order to say yes, it's legit or this is not legitimate. So be advised.
The next header field is the authentication results. Sorry. The authentication results header. This particular field gives you the the authentication results that were carried out by the receiving server. And there are three pieces of the puzzle that you can take into consideration in case the sending domain has implemented them. The first one is SPF, Sender Policy Framework. Using this mechanism, you will declare the IP addresses that are allowed to send emails on your domain's behalf. And for example, if you receive an email from one IP and your server checks the SPF record from the supposed domain that you have received the email from and you see that it isn't there, then it will be failed. The second one is DKIM, Domain Keys Identified Layer. In this mechanism, you use encryption keys and a digital signature to make sure that the email itself wasn't forged, and it is also used to check the integrity of the message, to see if it was altered in any way during transit. And the last one is DMARC, Domain-Based Message Authentication Reporting and Conformance, which basically unifies the previous two authentication mechanisms and lets you decide what would you like to do in case an email hasn't passed either SPF or DKIM. Would you like me to reject them? Would you like me to send them to the quarantine? Or would you just like me to stamp them that they have not passed DMARC and allow them to go to your organization? And of course, you can create custom filter rules in your email server to handle them accordingly, whatever your internal processes. Another funny header that I always have fun looking at is the reply to header. The reply to header is optional sometimes, and it is used to specify to the email client where to send the reply. Where do we want me to send the reply in case I receive a message? Some email clients use the from address and some use the reply to. And in this particular example, the attacker successfully spoofed a legitimate sender, added some information in the message body stating, hello, this is John Doe from Chase Manhattan Bank. I need your credit card information because we need to do a update on our server, something like that. And he manually changes the reply to address to be an email address that doesn't belong to the bank. It's an email address he owns. And if the recipient isn't careful enough, he says like this, okay, thank you, John. Here are my credit card details. Here are the banking statements. Here is everything. And then he sends the message without knowing that he made a very, very big mistake. And last but not least, you will certainly find headers that are prefixed by the X letter. These X headers are usually custom-made headers that are used by the industry standards, by the companies that produce email server security appliances to create their own custom, their own unique headers. In that way, they will be able to create their own spam filters to assess their own virus verifications, scanning mechanisms, so on and so forth. You need to understand that this can vary. You can find a lot of configuration when it comes to X headers, and it is always best to consult the official documentation of your email server or of your email provider in order to make a correct assessment of a specific email. Otherwise, if you don't look careful enough, you may think that an email is legitimate when it is not. And at the end, after analyzing the context of the email and looking at the headers, you take a step back and think. Does the message context say anything? And what do the headers tell me? I correlate the data, and in case I find something suspicious or believe that something's not right, I go forward with the analysis, and my colleague Alex will present this further. Thank you.
Thank you, Jonas. So, if you recall, when we first started this presentation, I said that we should, when an email is suspicious, we should focus on data of interest. So, in the next slide, I'll show you how to analyze files and how to analyze links. So, if you receive a suspicious link within an email, and how and what are the steps for a file analysis. If you receive a file either via as an attachment or maybe a URI tag within an email. So, if you receive the file as an attachment, yes, you may save it, wrap it up into an archive, password protected, and set it to the malware analysis environment where you have full control. If you receive it via URI file, well, at first you actually won't know if there is a file or maybe just a web page. So what you can always do, in the same malware analysis isolated environment, you can perform wget. I always encourage you to use common user agent string. So in my example, I have used Chrome user agent string because this will tell the web server that hosts that resource there that actually I came from a Google web browser and not using wget. Hopefully you will get to your HTTP request, you will get it handled okay, and you will be able to grab the content. So, the analysis for today, based on what we have seen during this year, it will be on more documents that contain VBA code. So, I have grabbed a few examples, and I'll show you manually how to deobfuscate and understand the code inside, the code within the document. So, the next step would be to confirm what type of document are you dealing with, because, of course, you may receive different types of documents within an email. So, you should always take a look at the file's matching number, which usually is around 2 to 4 bytes at the beginning of the file. In this particular case, it's quite specific, so it's on the first 8 octets, and this will give you consulting internet to give you the details about the file. So now, based on this file signature, I know that I am dealing with Microsoft Office 97-2003 document. What it does not tell me is that what is it? It's a PPT, it's a XLS, it's a doc. Maybe I do not know, and I'm not having that information at this point. Always consider using and run some strings on your document, and please focus only on things that you are able to read. This is the way I'm doing things. So there might be lots of offsets with lots of ASCII strings that I'm not capable of reading. So I'm not saying they do not mean anything, the big puzzle, but I'm focusing on things like when I see normal.m and Microsoft Office Word, so normal.m stands for the default template of Microsoft Word documents. I know that from the matching number that it's an Office file, so now I know actually that it's a Microsoft Office Word document. I see things like this document, VBA project, so this tells me that this document contains VBA inside, so it has VBA script and additional stuff. Okay, so if the document contains VBAs, the nasty stuff will definitely happen when it will be executed. So one tool that you can use is OLEDVBA. It's a Python script, part of the OLED tools suite, and it has, just by running it with a -h, it will tell you exactly how you can use it. So I have used it with the --deobf, which stands for deobfuscation, which says, you know, I'm going to analyze the VBA and I will deobfuscate the code and I'll give you some awesome input. Well, it's not quite capable of deobfuscating it, but instead, yes, it does give you some details about the document, which considers to be suspicious. And yes, just by taking a look, there are suspicious. When I see autoopen, create object run, autoopen stands for the autoopen subroutine VBA, which basically, if you have some piece of code there, a macro, and you double click on the document, you are going to open it, and the macros are enabled, so all the code will be automatically executed. It has the capability of creating objects. It has the capability of running stuff. Basically for things. Hey, why do we have, why should I expect to have something encoded within my document? Yes, so this just rings some bells, but at this point, I don't know exactly what the malicious character is for this document. I have just eliminated some of the output because this command also gives me the code itself. So you can grab it using Python, being in a control environment, you can open the document and get it from there. Well, there is no easy way of doing things, and eventually you find something like this. So yeah, you do not have to be discouraged. When I see something like this, I just take a step back and I'm just trying to understand one step at a time what the attacker is trying to achieve here. So I'm not a programmer, I have some scripting skills knowledge, and when life gives you lemons, make lemonade after that, so take it just one step at a time. What I have did here is that I have identified, hey, so I have a subroutine, got auto-subroutine, a couple of functions, of course there was a lot of code here, and I start to watch the math out of the code. And when you see a function like this, I said to myself, why in the world would I like to manipulate something that is like this? Why not having it like this? So the first thing I did, I just modified the variables to something that I am capable of reading, and I have taken a look at the function itself. So I can see that it has parameters, a string 1 and a variant, and it returns a Boolean values, which can either be true or false. Simple as that. And then just by looking at the code itself, it has a for each construct, and it's just trying to compare, make a comparison between the whole elements residing in this variable with the elements residing in the var1. If the magic happens, then it will return true. If not, then it will return false. But we cannot see that in the code here because it's not telling us that. But we know that the default value for booleans in VBA is false. So that's why if this will not happen, it will return false. And of course I have tested it. So this is the function, beautified, and this is the way I have tested it. And put just the output, put it on the screen. So this function, true or false. What you need to understand, and of course you know it already, if the function is not being called anywhere inside the code, then it's useless. It's correct, I do not have a problem with it, but the attacker never uses it. So yes, I have identified a lot of functions like this, which actually do not do anything inside the code. I'll just put them by the attacker just to confuse you. And I have focused on things that really are important in the code. This is from previous examples, I don't know, maybe found during the summer. Things are starting to change and I will explain to you. So these are just samples grabbed from multiple files. And yes, I said that I'm going to be focused on what really is important. So that capability of creating objects and running stuff. That capability of executing shells. So what the attacker did here is just he manipulated the built-in document properties and he created some custom document properties. Those are just strings with data. And using the read function, he just extracted data from there, from those strings, and then he created an object which, as you can see, I manipulated the data, and K actually, which is G plus E, means VS Script shell. So it's trying to create an object, a VS Script shell object. And then it's trying to run the G here, which, again, using message box, I can see that it actually stands for PowerShell minus E, and the encode is basically for command. As I said, things start to change, and now they are not even bothering of doing such things. They are just putting in the strings directly within the code. They are using maybe multiple modules, but they do the same. So the main difference is that here they just say start from character 5 and go until the end of the string. Here they say, hey, start with the 25th and go to the 195 character. In the end, they just try to concatenate the stuff and execute it. Well, I saw things like this, and they were actually, I did not know at that time what they were because I was not able to find them anywhere inside my code. And I said, okay, why I should not be discouraged by this, type name, and think this will return to me empty, which told me that, hey, it's something that is not defined. It's not an integer, it's not a string, it's nothing. You can just do not care about it. Once you have the data like this is just a snapshot, you cannot manipulate it. So I took the output and put it within a text file. And now when you think that yes, I'm done, definitely now I know exactly what the attacker does, but you don't, because you received things like this. So yeah, this was what we have seen first, and this is how things are looking right now. Here it was a little bit difficult because the information is very, very scrambled, but I started with the following logic. So, hey, I have started with a PowerShell string. So once, PowerShell encoded, base64 string. Once I'm going to decode it, it will be also a string. So I will have command after command after command after command, so I need to identify an end-of-life terminator, which is semicolon. And it gets quite easy when I have identified this -f, which stands for the format operator, which basically says in the right output of the command I have an array of strings, and in the left output I will tell you how to rearrange them. So if you take a look here, this stands for new minus object. And everything just is a match for the whole code. In the right section, this is something quite recent. They are not doing it like this anymore. They are just creating a very, very large string, which is separated by these characters here. So when you see the split method being invoked with many characters, you should know that it will perform a split by each one of them. And of course, I have done it. You eventually see something like this. And what the attacker is doing. So for each object in this string, the first thing it does is leveraging the convert2 to int16 method to convert all of these numbers, which are given as string, in base 8. And then, using the char function, I will grab that ASCII integer and turn it into an ASCII string. Okay, no problem for me. I'm a Python fan, so this is done in Python. So I took all those data from here, all of this data from here, put it in Python, and execute it to obtain, because I really need to want to be able to read this. In the end, no matter what the case will be, you will find something like this. So this is the final version, deobfuscated and beautified. So if you take this piece of code, put it in a PowerShell script, execute it, tell me it does nasty stuff. Trust me. So, what can we see here? So, the administrator creates 3 objects. It defines 3 variables. The URLs variable, it was quite long, and this is an array of strings, because here at the end it was invoking the split method by comma, so it had one URL split by comma from the second and the third and the fourth. And he eventually, for each one of the elements within the URLs, it attempts, by leveraging the web client object, to download a binary, to store it in the local temp folder for the user, and it will give a random number name from 1 until 65,536, append the exe extension, and run it. If I'm able to do so, then break and the script, and so on and so forth for each one of them. If the try block would not be able to be executed, so the exception, it will be thrown within the catch section of the try catch block. And this just returns an error message on the PowerShell command, which is not visible for our user, because here, so yeah, is this parameter here 0, which stands for hidden. So it does not everything is hidden. And here in the bottom right corner is the way, because we have dealt with some basis for encoded strings, I have decoded also using Python. You can do it even online, but I do not recommend it. And here is the way I have converted those, so starting from the ASCII integers to ASCII strings to have it like this. At this point, when you conduct phishing analysis, you of course are focused on obtaining those indicators of compromise in order to implement the proper blocks in your environment. So yes, we started with the context analysis, gathered the information from the headers, we conducted some analysis on the code inside this file. Yes, we can block the sender. You should consider it twice if you're going to block a domain on IP. I do not recommend it. You should bind the initial URI value or the hash of the initial file. you can even, of course, these URLs here also they need to be black, and you can consider proceeding with the analysis of this binary. There are three ways that I'm thinking here on how you can get that binary. The safer one is to grab a URL class from here, just the domain, go to Aristotle, put a domain, make a search for that, and see if it is a match for reputation, and then try to identify if for that domain there is an identical URL path with the one that you have here. Then go to that particular URL, so not search for the URL path directly, just search for the domain, and then if someone already submitted it, just click on it and see what was the result at that point. If hopefully you'll get it to 100 OK, and the hash value. Well, that hash value, it will be the hash value of the binary downloaded from here. Grab the hash, fire total intelligence, it will allow you to download the binary. Another way of doing it, start the Wireshark, run this, and extract the binary from Wireshark. Or download it directly on either of these locations. You can perform some dynamic analysis on the executable, which I did. Fake DNS, Wireshark, Rakeshot, Process Explorer, Process Monitor. In the end, this turned out to be a Trojan, but I was not able to see any C2 traffic. It just ran. It was I have seen that a process in my task manager. It deleted itself from the temp. It deleted itself at some point from the task manager. I have waited, nothing happened in my virtual machine. I have correlated this information with the information I said from hybrid analysis, just searching for the hash. They had the same conclusion, so nothing happened at the network level, no sort of traffic, no additional details that I could have used. If you are a big fan, you can run some static analysis. So if you are good with that, yes, sure, take the binary and work it over with it. But for me, at this point, yes, I do have the indicators compromised. I know that this was nasty. I haven't created the correct bugs in my environment. So at this point, I should be safe. Why do I encourage doing it like this? Because when I have first seen that Word document and calculated the hash and went to some sandboxes, public sandboxes that some people already used, there were no network indicators. And this is not true because I have proved that there were lots. So, and when I just arrived here and I was able to see HTTP, I have managed. So, how can you tell me there are no network indicators? Either A, the attacker script is not good, it's not working, or B, maybe you are not able to detect it via sandboxing and things like that. That was about it for the file analysis. But what happens if we receive a link within the email's body? Again, double get, grab a link in the same control environment, throw it into a hex editor, and look for things like this. In the end, I have a little disclosure to it, so this in the end it will be a credential harvester, but I'll show you what was really interesting about it. Look for things like, if it's in plaintext HTML, specific HTML tags, head, body, script, things like that. And then, please feel free, and yes, I have opened it in a text editor. What caught my attention here was the usage of the unescaped JavaScript function, which, guess what, unescaped those strings here. And it was evaluated, so the output of this command would be evaluated. What escaping coding means is that instead of showing you the actual character, it will show you the hexadecimal value of that character. Once I have decoded those, I received this. So the first line gives me this, and the second line gave me that. Why was this really interesting? So here things are starting to get exciting. The adversary is using his own custom-made encoding algorithm. So this function here is a custom-made encoding algorithm, and I'll show you exactly what the attacker is doing here. First, in this function, which has just one parameter, which you can see is being called here, it defines just one variable rule string. Then, in the temp variable, it conducts a split. So yes, this string at some point had this string inside of it. So the section on the left was stored as the unescaped version of it. and the section of driver stored in K, the unscaled version of it, plus this string here. And here, the magic happens. This is the thing that is really custom, and hopefully I can remember exactly what is happening here. So, the first thing that happens is that the result between I, which at first is 0, the modulus result from I and length, it will return the length of a string. So between I and the length of K, which if I remember correctly, K was 13, so the modulus operation, which 0 modulus 13 is 0, and then K dot char AT of 0. This means that give me the element within K at index 0. So get me that first element. And then parse it if it converts it from string to integer. So I have one number. This symbol, which I'm not sure how to say it in English, stands for the logical XOR function within JavaScript. And so this number here, it will be XORed with s char code AT of I, which stands for give me the Unicode value of from s at the index I. So for the first element, it will be also a number, XOR them. The value is decimal, plus and minus 5 is the subtraction of 5. And in the end, the string from char code basically will tell us that it does the opposite of this. So, yep, convert that Unicode value into a string and then append it to R. And in the end, the function turns R. So he does that for every single each element. And yes, it will be written on the screen. So I have done it, of course, for a couple of, because it was no sense to do it for everything, but in the end, it will be something like this. For I equals 0, it will be this type of bracket. The second one will be an exclamation mark. So it starts contouring as a HTML document. And yes, it was an HTML. Nothing so special about it. It had a couple of JavaScript functions. The first one is just doing some validation on the input data of our victim in the email ID field. And why I just wanted to show you, because when you do it like this, you may find some little errors. So the attacker, at some point, this is just a piece of the function, it's not a whole function. At the point, he's trying to see, hey, if I have at the end of the string, so this is not a valid email address. So the email address cannot be it cannot be finished with an at. So you have x.y at something, so but never should add with an at. So why am I saying it's not correct? Because the index of method and the LSTR, which is the length of the string that the victim enters, so this starts at 1 and index of starts at 0. So when it tries to match for the end of the string with end character, it will always reach one element before the end of the string. So to do it right, here you should have LSTR minus 1, and that will be a match. Of course, it's not of big influence within the code, because you can see here he's using or. So when we have a logical or function, this means that just one of the verification, it's enough for just one to be true, so the whole output will be a match. Next, this other JavaScript function, yes, first verifies, so those two variables stores what the victim entered in the username, and in the password fields, it verifies that they are not null, then it calls this eCheck function to verify the validity of the syntax of the user's email, and in the end, you just have a form, an HTML form, sorry, know that, and we can see that when the user would click on the Autopsy button on the bottom within the page, the validate from other function will be called. We will do that validity check of the syntax, and leveraging an HTTP post method, all the credentials will be sent to the Office 365.php script. What I have done in this case, well, ban the initial the initial URI path, of course. And what I was really interested, of course, I have conducted some searches within my environment to see how many users might have clicked on this. Well, there are a lot. Really interesting was was there any traffic towards this script? Because if there was traffic to this piece of script here, it means that, well, I know that those users clicked on the button. I cannot tell if they entered something in those fields, but I can confirm that they definitely clicked on the button and there was traffic towards this PHP. Send them to security awareness training and wipe them until they confess that they did something wrong. And yeah, this is what you can get by conducting some manual analysis on the code. And here, I'm not sure, maybe if the attacker is among us, so yes, please be a little bit careful in the future. And thank you.